Hello, my dear students. Please subscribe our YouTube channel for more free video lectures and click on bell button for notifications and visit our website to purchase full course.
Hello, my dear students. Welcome to the session. Hope I think you have gone through this question number 16. Let us look at the solution of it. What is asking actually here? Vx of 0 plus. Voltage across resistor or voltage across inductor. Same procedure, right? Voltage across inductor or voltage across resistor. Other than voltage across capacitor at t equal to 0 plus, if it is asked, then you have to go for what? Step 2 only. But for that, you require step 1, construct t equal to 0 minus equivalent circuit. T equal to 0 minus equivalent, what is the position of the switch? Closed, right? This is closed. How the inductor is acting like? Short circuit. Yes or no? And what is your objective here? Your objective is to determine IL of 0 minus. Yes or no, all of you? Always in the first step, your objective is to determine current through inductor, voltage across capacitor. That's it. Okay? Irrespective of the problem asked here, it doesn't matter which problem is asked. If somebody is asking just 0 plus, whether it is current or voltage or anything it might be, at first step, at t equal to 0 minus, your objective is always to determine current through inductor, voltage across capacitor. That's it. Current through inductor, how much here? Switch is closed, this is shorted, this is gone. So resistor and short circuit both are parallel. The entire current passes through what? The inductor only. So which direction it is passing? This direction it is passing. Yes or no, all of you? Okay. Therefore, 2.5 amperes is the current flowing through the inductor. Now let's go with the step 2. Step 2, t equal to 0 plus equivalent. Then what is the switch position? It is open. Yes or no? Once it is open, now the current source and the resistor is one category here. Inductor and resistor is another category. And both have a common node, but there is no return path. Both are isolated. So I can neglect these two and consider only these two elements. And finally, you have the current source. The inductor is replaced by a current source with a parallel inductor model. Yes or no, all of you? Okay. With a parallel inductor model. And you got the resistor as it is. And this is 2.5 ampere. Okay. This is 2.5 ampere. And now this is 20 volt. Yes or no, all of you? So what do you get here? The current flowing in this element is what? Actually in this direction. How much current is flowing? This is 2.5. Then finally Vx value is 20 into 2.5. Okay. Then what do you get here? 50 volts. So what are the options given here? 50 volts or minus 50 volts? It's minus 50 volt. Okay. You got two options. One is a 50 volt, the other is a minus 50 volt. Because in the problem, he has mentioned clearly, okay, the polarities, actual polarities, what you are getting is plus minus, but he is asking with minus plus polarities. In the circuit, the polarities are given what? Minus plus. But you are getting the polarities what? Actually here, this is minus, okay, plus, he is asking Vx. So Vx of 0 plus. The polarities because of the current you are getting is plus minus, and the polarities that you want, okay, is minus plus. There is a mismatch between the actual polarities and desired polarities. That is why you get what? Negative sign. That's it. Understand all of you? Okay. So no doubt. So be careful in the four options. Plus 50 is there, minus 50 is also there. So you must be very, very careful. Question number 17. It was also asked in GATE. Find di of 0 plus by dt. Di of 0 plus by dt. This is Rs, this is Is. So 4 options are given. Okay. 4 options are given. di of 0 plus by dt. What is I? Current through inductor. First derivative term di by dt, where I is current through inductor. You can go for step 2 because this indicates VL of 0 plus by what? L. VL of 0 plus, if you know, then obviously you know di of 0 plus by dt. Okay. So VL of 0 plus, what is the procedure? Step 2. For that, step 1. To determine that, in step 2, you require step 1 t equal to 0 minus equivalent. At t equal to 0 minus, the switch is open and you would like to find the current through the inductor. I of 0 minus is 0. Okay, there is no capacitor, right? Okay, then step 2. Construct t equal to 0 plus equivalent. T equal to 0 plus, what will happen? Current source, resistor, switch closed, resistor. Inductor is acting like open circuit because current flowing through the inductor was found to be 0 at t equal to 0 minus. And now your objective is to find voltage across the inductor. To substitute here in the formula. Okay. Now obviously no current is flowing. This is neglected. And you got RS and IS. Entire current is passing through RS. Finally you are left with IS into RS. Therefore if you substitute that in the formula, di of 0 plus by dt is equal to IS RS by, what is this? L. Okay, VL of 0 plus by IS RS by L. Option B is the correct answer. Okay, option B. That was given in the 4 options. Four options are given. Let's go with question number 18. Question number 18. '17 was completed. Finish that, all of you. Question number 18. This question was asked in GATE previous. Assume that the switch S is in position 1 for a long time and thrown to position 2 at t equal to 0. At t equal to 0 plus, the current I1 is, that means I1 of 0 plus is asking. Okay, let me draw the circuit. Let me draw the circuit. This is C, this is capital R, this is L, this is I2 of t, this is I1 of t, capital R, and this is C. So what is happening here at t equal to 0? At t equal to 0, okay, the switch is moved from position 1 to position 2. Is expecting to find it is expected to find I1 of 0 plus. Okay, all of you go through that question clearly. You can understand. You can also start doing that problem. Meanwhile, I just take it off. Okay. Current through what? I1 is what actually here? Current through what? Current through a loop, right? It's not current through inductor. It looks like current through inductor, but it's not. Because what is current through inductor actually here? Current through inductor is, it is common to both the loops, right? I1 and I2 result in I1 minus I2 or is I2 minus I1. So I1 is not current through inductor. In fact, I1 is current through capacitor. So other than current through inductor, what is the procedure to find current at t equal to 0 plus? Tell me. Step 2 only. That's why I was telling you, constructing t equal to 0 plus equivalent is very, very important. For that, you require in step 1, t equal to 0 minus equivalent. At t equal to 0 minus, what's happening here? Step 1, the switch is at 1, let us say, position 1. Capacitor is acting like an open circuit. Inductor is acting like a short circuit. This capacitor is open. Yes or no, all of you? Okay. Now let's see. Let's say this is VC1. Say this is VC2. Say this is IL. Understand? Okay. Because I want to know what is the current and voltage of these. When the switch is at 1, it looks like this. Let me draw the circuit. Okay. Acting like open, acting like short, and acting like open. Okay. Now this is a capacitor. This is also capacitor. This is an inductor. So tell me now, what is IL? IL of 0 minus is 0. Yes or no? Because this is open, you can't expect any current here. What is V1? VC1, sorry. VC1 of 0 minus. See, VC1 of 0 minus is the total voltage is appearing across this. Yes or no, all of you? These are the two terminals, right? So, this is the voltage. What is the voltage actually here? V. What is VC2 of 0 minus? The voltage across the short circuit. So, 0. So, I hope you understand the point now. Based on this information only, you can construct the t equal to 0 plus equivalent. T equal to 0 plus equivalent can be constructed. Switch is at 2. Yes, 2. Okay, this is at 1. Now, the capacitor can be replaced by what? Voltage source with a series capacitor model. Plus minus voltage V. Inductor is acting like open circuit because current flowing through the inductor at t equal to 0 minus was found to be 0. Now this resistor remain resistor. This capacitor is acting like just a short circuit. This is the capital R. Understand all of you? Okay. Now you require the current here I1 of 0 plus. Sir, all of you, if you look at this is an open circuit, this entire path is closed now. This is also capital R. Okay. Now one voltage source, two resistors in the loop. Then finally, what is the current here? The current of, okay, the current I1 of 0 plus is V by R plus R, that is 2R, okay, R plus R. But the positive polarity is here, negative polarity is here. Therefore, the current leaves from the higher potential and goes like this. But you require in opposite direction. The actual current is in this direction. The desired direction is this direction. Therefore, there is a mismatch. Minus V by 2R. That's it. Okay. The options are given already. Option A is correct. Minus V by 2R. Minus V by 2R. Question number 16. Not 16. It was 18, right? Now it is 19. Now it is 19. 19th question. This question was asked in the previous IES papers. Let me draw the circuit. You complete that, all of you. Plus VC. Is asking what is VC of 0 plus and VC of infinity. It's a very simple question, straightforward question. You can easily do it. Okay, that problem you can do it. You must be in a position to solve the network without constructing equivalent. You should have command in solving the networks. I'm telling you, you need to save a lot of time in the exam. Okay, T equal to 0 plus equivalent circuit is very, very crucial and critical. I'm telling you, in all problems. In all problems of transient analysis, T equal to 0 plus equivalent circuit is very, very important. And 99% of the problems are given in the transient analysis, okay, are based on the T equal to 0 plus equivalent only. So you must be very, very careful. Do that all of you. Meanwhile, I just note down another problem, question number 20. This was also asked in IES. It's a very interesting problem. Of course, simple problem. You can do that. That problem you can complete. Meanwhile, I take another problem here. This is C, 2C and C. This is L. This is 4 ohm. This is 2 ohm. This is 18 volt. The initial value of the current through the capacitor 2C is, that means I2C of 0 plus is asking. Okay. Now, I think you got this answer, right? VC of 0 plus is asking. Voltage across capacitor T equal to 0 plus. I think first step itself you will get the answer. Yes or no, all of you? T equal to 0 minus you construct first. What is the voltage across the capacitor T equal to 0 minus? Switch is open. Okay. This is open. The resistor is isolated. Entire current is passing to this. Therefore, VC of 0 minus is, okay, the voltage across these 2 points is nothing but voltage across these 2 points. The voltage across the resistor, switch is open. So 1 into 2, this is 2 volts. So VC of 0 plus, therefore, is nothing but VC of 0 minus, nothing but what? 2 volts. But he's also asking T equal to infinity conditions. Okay, VC of infinity. For VC of infinity, this is shorted. Yes or no? This is shorted. And this is open. Yes or no? Okay, this is shorted, this is open. Because at T equal to infinity you're talking about. Then what will happen? What is VC of infinity? What is VC of infinity? What will happen? 0, right? Yes or no? This is open and this is shorted and voltage across the short circuit, 0 volt. That's it. Go for next problem. Question number 20. Question number 20. What is the voltage across 2C is asking? I think all of you understand this, right? At T equal to infinity, the capacitor is open, the switch is closed. If it is open, then voltage across these 2 points, nothing but voltage across short circuit, nothing but 0. Okay? So this is how you do the problems, okay? Very simple problems are asked in both in GATE as well as IES. But T equal to 0 plus equivalent circuit based problems are very, very important. Let me give another problem, which was asked in IES. It's a very interesting problem. You do that, all of you? You make an attempt. Meanwhile, I just note down another problem. This is A, this is B, t equal to 0. T equal to 0. This is capital R. This is 3 ohm. E1, E2. 2 Henry. This is I. What is given actually here? I of 0 is given as minus 8 ampere. Di of 0 by dt is given as 3 amperes per second. I of infinity is given as 4 ampere. Okay. Then he's asking capital R value. Okay. Well, first let us solve this problem. Then we will move on to another problem. Okay. 20th problem. All of you, I think you have done some part of it. Okay. So current through capacitor T equal to 0 plus. For that you require step 1. What is it step 1? Step 1 here. Construct T equal to 0 minus equivalent and find current through inductor voltage across capacitor. Irrespective of the question asked here, your objective in the first step is always current through inductor voltage across capacitor. Okay. So let us construct that. Inductor is acting like short. Capacitors are acting like open circuit. Switch is actually in open condition for t less than 0 or t equal to 0 minus. So what do you get here? I get something like this. Let me draw it clearly. This is open. Okay, this is capacitor C. This is 2C. This is inductor. And you need to know what is the voltage across this V2C of 0 minus and VC of 0 minus. What are the values? What is the value of IL of 0 minus? All these things are very, very important. 18 volt. Okay. Now, since they're all open circuit, the entire current is passing here. I can say here IL of 0 minus is 18 divided by 2 plus 4, 6. That is nothing but 3 amperes. Okay. Now, the two capacitors are connected in series. Yes or no? Because it is open, two capacitors which are physically present are connected in series. And these two series capacitors are connected across what? 4 ohm, because it is acting like a short circuit. Now the voltage across 4 ohm will be divided into two parts. I hope you understand the point. This is very important point to be observed in the calculation point of view. Okay, to find V2C of 0 minus, VC of 0 minus. Okay, these two are connected in series. The two capacitors are connected in series. The voltage across 4 ohm will divide into two parts because they are connected in series. But what is the voltage across 4 ohm? The voltage across 4 ohm will become, because it is shorted, already you know this is 3 ampere. So 3 into 4, that is 12 volt. Okay, this 12 volts must be divided into two parts. So V2C of 0 minus is opposite. How much it is? C by C plus 2C into 12. So what's happening here? 3 4 volts. What is the remaining voltage? VC of 0 minus 12 minus 4, 8 volts. Understand all of you? Okay, this is 4 volts and this is 8 volts. Clear all of you? Okay. Now what is he asking? He is asking what is the current flowing through this. For that you require T equal to 0 plus equivalent. T equal to 0 plus equivalent. How do you construct that equivalent? Let us look at this. Okay, this is resistor. Inductor is acting like a current source. With the parallel inductor model, we have seen that equivalent. The switch is closed here. And now this is acting like what? a voltage source with a series capacitor model. Again, a voltage source with a series capacitor model. This is 8 volts. This is 4 volts. Okay, let me just erase this part. All of you understand how we are constructing T equal to 0 plus equivalent? I just followed our usual procedure, okay? Now, what about this 2C? Now, you are expected to determine current through 2C. This is what actually is asking. Okay? Now, how do you do it? This is 18 volts, 2 ohm, 4 ohm, right? 4 ohm. And what about this current? How much it is? 3 ampere. Yes or no? Okay. This is an inductor model, parallel inductor model. Now tell me, how do you find this current? To find this current, since it doesn't have any resistor, okay, you need to apply Kirchhoff's current law at this node. Yes or no, all of you? Okay. But to find the current here, you must know current here. But what is the voltage across this particular element? 4 volts. Directly the voltage is appearing across it. So 4 divided by 4 is nothing but 1 ampere. Understand all of you, okay? But you also know that the total voltage is how much actually here? 12 volt. Okay, that means if it is 0, this is 12 volts. Now 18 minus 12 by 2. 18 minus 12 is 6. 6 by 2 is how much here? 3 amperes. This is 3 ampere. So 3 amperes is entering. 1 ampere is leaving. The remaining current is flowing through this particular capacitor. So finally, when you apply Kirchhoff's current law here, because I need to apply Kirchhoff's current law only, there is no other option. Because this path doesn't have any series resistor. Yes or no, all of you? When there is no resistor in the path, to find the current in that path, what is the procedure that we have discussed already? KCL at this node. Now KCL to apply, you must know current here and you must know current here. To know the current here, since I know the voltage, 4 by 4, 1 ampere. And since the total voltage is available here, it is 12 volt because 4 plus 8, okay, 12 volts is available here. 18 minus 12 by 2 is nothing but 3 amperes. 3 minus 1 will give you 3 minus 1 will give you 2 amperes. This is your answer. Understand all of you, okay? There are 4 options given. Option C is correct. I think all of you understand this. Okay, you need to be very, very perfect in solving the networks. I'm telling you again and again. Do it, all of you. Complete it quickly, all of you. Complete that. You complete that part. I just remove only this part, which is available in your material, in your handout, classroom workbook. Meanwhile, I just note another problem. Question number 21. Please complete that, all of you. Question number 21, which was asked in IES. Okay, so this is A, this is B, T equal to 0, 3 ohm, E1, E2, 2 Henry. Given data, I of 0 is minus 8 ampere. di of 0 by dt is 3 amperes per second. I of infinity is given 4 amperes. Then the question is capital R is how much? Hope I think all of you finished that problem, right? So now let's go with another problem here. Question number 21, classroom workbook. All of you go through that question clearly. Some data is given. Okay, some data is given here on the given network. I of 0 was given. What is I actually here? Look at this, all of you. Observe the network. What are the elements that you have? Voltage source, resistor, 2 Henry, nothing but what? Inductor. Current through inductor I is given. I of 0 is given. Nothing but I of 0 minus 0 plus, both are same. Because it is an inductor, current through inductor may not change instantaneously. di of 0 by dt is given. I of infinity is given. Final conditions. Okay, now you are expected to determine the capital R value. Okay, so let's solve that problem. Whenever this kind of conditions are given, first you apply those conditions to the given network. Understand all of you? Okay. What are the conditions you want to apply? Since you have 0 minus conditions available here, or 0 plus conditions available here, and infinity conditions available here. Now first you apply infinity, let us say otherwise. First if you apply infinity conditions, t equal to infinity conditions, first we apply. If you apply infinity conditions, where is the switch position here? Switch is at B, right? Yes or no? Switch is at B. Once it is at B, inductor is acting like a short circuit. It is something like this. Inductor is acting like a short circuit. And something like this, minus plus. And this is at B now. The switch is at B now. Now what is this actually? E2. And this is what the short circuit. And the capital R. What is the current flowing here? I. I is the current actually here flowing. Nothing but I of infinity. Yes or no? Because for infinity you have drawn. The current flowing through this resistor is now in upward direction. This is plus, this is minus. The drop across this one is R into I of infinity. But polarities of the voltage is given here. Minus is connected to plus, plus is connected to minus. That means there is a mismatch in the polarities. The voltage across the resistor is E2 also, but with the reverse polarities. The voltage across the resistor in terms of I of infinity is E2 is equal to minus I of infinity into R. What is I of infinity given? 4. So minus 4R. This is the first condition you got. Okay. Now let us also construct t equal to 0 plus equivalent, or else if you can draw the circuit for t greater than 0. The switch is at B and you write the differential equation. If you write the differential equation, this is an inductor, this is a resistor, this is minus plus, and the switch is at B. Okay, switch is at B. Now let us write the equation here. I of t, L and R. What do you get? E2. Tell me, what do you get? What do you get? Minus IR, minus LdI by dt, minus E2. Nothing but IR plus LdI of t by dt. Okay, plus E2 is equal to 0. Okay, I of t into R. Let us now apply t equal to 0 plus conditions to this network. I mean to this particular equation. So what do you get? I of 0 plus into R plus L d I of 0 plus by dt plus E2 is equal to 0. You already know the values here. What is I of 0 plus? It is minus 8 minus 8R. L di by dt. What is di by dt? 3. L is how much actually here given? 2 Henry. This is 2 Henry. Okay. So 2 into 3, that is 6 plus E2 is equal to 0. Equation 2. Let us substitute equation 1 in equation 2. 1 into, then what is the result you get here? Minus 8R plus 6. Yes or no, all of you? Minus 4R. Okay, minus 4R is equal to 0. Minus 8 minus 4 minus 12R plus 6. Therefore, R is equal to 6 by 12, finally 0.50. Understand all of you? Okay, the same problem can also be done in this way also by constructing t equal to 0 plus equivalent. Because already you know t equal to 0 plus conditions. Why can't you draw t equal to 0 plus equivalent circuit? How does it look like? Tell me all of you. You know that di of 0 plus by dt is nothing but, since it is current through inductor, VL of 0 plus by L. Okay? If you construct that t equal to 0 plus equivalent and try to find what is VL of 0 plus, okay, you find what is VL of 0 plus from the network, and also you know what is the VL of 0 plus from the data given. What is VL of 0 plus actually here? From this you can find that VL of 0 plus is equal to how much, Nana? L into, okay, di of 0 plus by dt. Di of 0 plus by dt. How much it is? L is nothing but 2 Henry, and this is 3, this is 6 volt. Now if I draw that equivalent circuit, it looks like this. VL of 0 plus. This is plus minus VL of 0 plus. Okay, plus minus VL of 0 plus. Plus minus. Plus minus. This is E2. What is R value? R value remain R only here. What is the current source value? Current through inductor, how much it is? Minus 8 ampere. Yes or no, all of you? Okay. Now the voltage polarity is very clear based on the direction of current given. This is plus, this is minus across the inductor. So this is the inductor physically present. Yes or no, all of you? Now let's find that voltage. Voltage. What is the voltage here? Touching concept. What is the voltage across this? Plus minus minus 8R. Because the current direction is like this. Current direction is like this. Therefore, VL of 0 plus is touching negative minus of minus 8R. Okay, touching plus plus E2. Understand all of you? Okay. So what do you already know the VL of 0 plus here? 6 volts. Yes or no, all of you? Therefore, from this you can say 6 volts is equal to 8R plus E2. This is the second equation. Now once you substitute here E2 value, how much? Equation 2. What do you get here? E2 is nothing but what actually here? So I think we did a mistake here. What is that? You're touching, yeah, the polarities. Actually the polarities are taken wrong. This is minus, this is plus. Therefore you get minus sign here. Okay, you get minus sign here. Now if you substitute equation 1 in 2, then 6 is equal to 8R minus of minus, what is that? 4R. Then what do you get here? This is nothing but what? 12R, and from this you can get R is equal to 6 by 12, 0.5 ohm. Okay, you can solve either this way or this way. It doesn't matter. Just to make you understand, I have elaborated, but whichever the method you like, you can proceed. Okay. It is very simple that what are the conditions are given. From that conditions, you can draw the equivalents and then get the corresponding equations. Once you get the equations, you can solve them easily. Hope all of you understand this. You need a very good practice to solve the problems I'm telling you. You need a very good practice. To solve the problems, you require a lot of practice. And you must be good at solving the networks. Practice, practice, practice. That is the only mantra you have to follow, I'm telling you. There is no other shortcuts. You have to follow practice, practice, practice. Okay. So I think you have finished up to this particular part. Okay, please carry on with that. Meanwhile, I just note down another problem also. Question number 22. Question number 22. It was asked in IES. One farad. Here it is I of t. This is 12 volt. You are expected to find what is I of 0 plus. Okay. I think all of you understand this. For t greater than 0, I have taken the network. For t greater than 0, R remains R, L remains L only. Okay? Because it's a general network. T greater than 0. We don't know t equal to 0 plus or plus infinity or 1 second or 2 seconds. We do not know that. T greater than 0. Okay? I think you have done this. Okay? This particular part. Okay? Now, coming to this problem, current through a path, I of t, that is asking now I of 0 plus. Other than current through inductor, whichever is asked, you have to again go for step 2, t equals 0 plus equivalent circuit. Okay? So, for that, I go for step 1 first. What is step 1? Construct t equal to 0 minus equivalent. Construct t equal to 0 minus equivalent. So, in the construction of t equal to 0 minus equivalent, look at this, what are the elements present first of all. Okay, let me check once. This is not a resistor, this is a inductor. It is clearly given 1 Henry nana. Okay, so please go through that question once. You will understand 1 ohm, 1 Henry, 1 farad, 2 ohm, 12 volt. And current through this particular path at t equal to 0 plus. At t equal to 0, the switch is being closed. Okay, it's very clear. Now t equal to 0 minus, the resistor remain resistor. Resistor again remain resistor. Inductor is acting like a short circuit. Yes or no? This is open. This is also open. The resistor remain resistor. This is 1 ohm. This is 1 ohm. This is 2 ohm. And this is 12 volt. This is a capacitor plus minus VC of 0 minus. This is an inductor IL of 0 minus. Our objective is always IL of 0 minus, VC of 0 minus in this step. Okay. So open, then entire current is passing here, right? Therefore, IL of 0 minus is how much? IL of 0 minus is how much? 12 divided by 2 plus 1. Yes or no? Okay. 3 4 ja. 12, that is 4 ampere. What is VC of 0 minus? Since 4 amperes is flowing here, 4 into 1, that is 4 volts. That is 4 volts. Yes, sir, all of you okay? Okay, got it all of you? 12 by 3 ohm, nothing but 4 ampere. And 4 into 1, nothing but what we see of 0 minus. Because it is open, the voltage across these two terminals is nothing but the voltage across these two terminals. Nothing but voltage across these two terminals. Nothing but voltage across 1 ohm. That's it. Now let's go for step 2. Construct T equal to 0 plus equivalent. How does it look like? Network looks like this. Look at this, all of you. This is a 2 ohm resistor. This is 1 ohm resistor. The inductor is acting like a current source. It is replaced by now at T equal to 0 plus. Always practice only in this manner, I'm telling you. Okay, current source with a parallel inductor model. Voltage source with a series capacitor model. You remember that because there are special problems involved. Okay. Plus minus. And here is a resistor. Now switch is closed and here it is asked I of 0 plus. What is this? 4 volts. This is a capacitor. This is 1 ohm. This is 1 ohm. Now I want to know the voltage across this particular path. That means there is no resistor. When there is no resistor, KCL is the only option. Okay. How much current is flowing on here? This is 1, not 1, right? How much it is? 4 amperes, right? This is 4 amperes. And now to apply KCL here, you must know current here, already known. You must know current here. For that, you take the voltage directly here. Yes or no, all of you? 4 volts is appearing across 1 ohm. Therefore, 4 by 1, 4 amperes. Now 4 is entering, 4 is leaving. Finally, I of 0 plus is 4 minus 4. That is 0 ampere. That's it. Okay. So options are given here. Minus 4, 0, plus 4, 12. 0 ampere can be chosen. Option B is the correct answer. Okay, so I stop the session here. And this is how you need to look at the problems. There is no end for the problems, I'm telling you. There's so many problems like this, but the concepts are same. If you are really good at in constructing T equal to 0 plus equivalent, okay, I'm sure that you are master in initial conditions. If you are master in initial conditions, you are master in transient analysis. Understand all of you, okay? Well, so we will meet in the next session. Another interesting concept we will try to learn, okay?